Good afternoon. My name is Ke Deng, and I'm the course coordinator of this course, Big Data Processing. Today is the first lecture, and glad to see you guys here. And we have 128, less than 130 students enrolled. So I think it's half is here. That's good. Okay. First of all, we acknowledge this land, MIT. The traditional owner is the Waru-Jerry people of the Kulin nations. The constellation of the MIT, acknowledged. Today we mainly introduce the structure of this course, Big Data Processing. First, the course organization, okay, the prerequisite knowledge, and how to communicate, how to get information, how to communicate with me, with your fellow students here, and how to check all the information about this course. Then we introduce big data, then the course review, and the lab information and assessment. So I received a number of emails to me say, okay, they didn't pass the advanced programming, whether they can enroll this course. The answer is quite clear. This course requires advanced programming in Java. If you don't have the background in Java, you have a risk to pass this, when you're working on the assignment. It is a high risk because you even cannot follow in the labs. This is a big issue. So I'm pretty sure you guys sit here have confidence in Java. I also received an email about the Python. Okay, Python can be applied to all assignment in this course. You can use Python. You can use Java, but based on the Hadoop environment. Hadoop environment is naturally incorporated Java. And also, we suppose you already have background in Java, not Python. So if you are good at Python, but in this course, I'm sorry, I cannot assess based on Python because of the teaching resource available in this course. This course has been well defined based on the knowledge of most students in the previous study in MIT. Also, you need to know the database concepts because we are talking about big data processing. How to manage data is an important aspect. So to avoid you feel anxious at some stage of this course, so I suppose you already have at least you know what is SQL about. Okay, what you know about John, of the basic ideas about the concepts in the database. We have 2-hour lecture, that is this time, weekly. Until the end of this semester, we have one semester break. Besides that, we have 12 weeks lecture. I'm the lecturer and the course coordinator. My office is in level 9. In the corner, maybe you'll take some time to find my office. I'm very hidden in some corner, at some corner. You can send me an email if you want to talk with me. But of course, if you pass my office, I'm inside. You can knock the door, and I will give time, share my time with you. Because during the teaching period, requests from students, from you guys, are my first priority. So I will process whatever you request at the highest priority. You also can find my phone number from the website. Type my name, KEDNG MIT. You will find my office phone number. Besides that, we have the lecture, we have the lab. The lab is 2 hours as well, because this course is very practical one. So we want you to have a hand experience, first-hand experience about the Hadoop, about the big data processing framework, and also a list of tasks you need to programming, work on the real system, and get the result. So we don't have a tutorial. We have a 2-hour lab. You can call it a tutorial, does not matter. It's a 2-hour session. You have a list of tasks to do during these 2 hours. Of course, the 2 hours is not enough. You will soon quickly find 2 hours in the lab is enough. But we provide the system. You can access the system when you're at home. To access the Hadoop in the AWS, you can work out, continue your, if you cannot finish your task in the lab, you can continue do it at home. The tutor, I will take, I'm not quite sure we have 4 labs or not, or 3 labs, based on the eventually the number of students enrolled in this course. I may take 2, another tutor take another 2. Andrew Radic. Andrew Radic is he's the director, one of the director in the ITS in MIT. So we are lucky to get him as a tutor. He is very knowledgeable, so he can solve almost everything you encounter in MIT. So that's really good. We have Andrew with us for this year. I go to the timetable. I didn't see any students already enroll for the lab. So you need to enroll in the lab. That's proper time to you, because if many questions asked, we will serve the students enrolled in that particular lab, such that we can properly allocate our time. Also, at the end of this, the week 12, you will have a presentation. The presentation is basically based on the name list enrolled in that lab. So it's better to take your time quickly to enroll the time suits you the best. I'm pretty sure, because this is not, you guys sit here, that means you already studied for at least half a year, so you should know how to enroll the lab. If you have any question, okay, go to the ITS, the Building 80, Level 3. They will help you to solve the problem. In this course, of course, we use, as any other course, we use the Canvas manager, all the learning material. Let's see. I suppose you already know everything about Canvas based on previous study, but I still want to quickly go through it, because there are many information you can find directly from the Canvas. So the announcement, if there is an important message I need to pass across the class, I will make announcement. At the same time, I will send an email. Announcement and celebrate. This is another important information you need to pay attention to. It indicates the weekly learning material, the topics, also the deadline. You see the deadline of the assignment. We have one assignment, but we have weekly task. That is from the week 1 to week 10, every week you have a deadline. That is graded assessment. This is important. Don't miss it. Don't miss the first, particular first, that is due next Tuesday, midnight of next Tuesday. So even though the question is not really challenging, but it is important. You need to pay attention to the deadline, weekly deadlines. So this is important information you need to be aware of. This is the module. The module, this is from the view from lecture. So if you look at it, you will have a view look like this. You have a view look like this. I will post the material week by week to manage the progress. From here, you can find the lecture notes. Lecture notes I will upload it after the lecture. I will maybe include the feedback of students and restructure it to make it more presented in a better way. So I will upload it afterwards. For this week, you are asked to read this. You can call it a textbook, but actually it is not textbook. It is a document written by a professor from Canada. It's Maryland. Now the professor is in Waterloo in Canada. So this size of this book. So this is the electronic version. You can print it out. It is better to print it out, I strongly suggest, because based on my reading experience, you need back and forth to check the concepts. So, but of course, if you have Kindle, you can still use Kindle to read it. It depends on you, what you prefer. The first lab will start from next week. So go to enroll your name in the lab. You may find that the discussion is very useful. So I break down the discussion based on the topics. So you can find useful information from there. For example, I already load something here that is, for example, the lab. For the lab, and I already post something that is a code developed by a student in previous year, and you may find helpful when working on the lab 4, in the lab in week 4. If you have any questions, you can see I subscribed it. Okay. Any information you posted here, I will receive an email immediately. Normally, I will respond to any message you posted here if you have any questions. I will involve in the discussion. As I said, during the semester, your request is my first priority. Any questions, I will process immediately, or as soon as possible. So this is the assignment. So far, there's no assignment listed here, but it will be uploaded online at the end of this week. When it is released, I will discuss in the lecture. Then, of course, alcohol is the recording of this lecture will be all listed here. I will try to transcribe the videos into words, text. So if you want to know more about a word, for example, the HDFS, you just type HDFS, you know where in the video talk about HDFS. So, okay, that's the canvas. This is the central of this all information shared dispersed in this course. Okay, another thing that is maybe not necessary, but still want to recommend, use your student ID, because the MIT system many times recognize if you are not using the email address out of the MIT, your access will be rejected. This is what I just talked about the information access, the readings, materials. In particular, I really encourage you guys come to the lecture, even though we have a recording. We try to make the recording the best for you to use, but come to the lecture. The lecture, maybe we have discussions and you miss the chance to involve in the discussion. This course, I should let you know, you will find, I will talk about a little bit more about the inside of this course. You will find it is not easy, it is challenging. Even though you have the Java background, the programming, the way to solve problem, it has its own specific way. To deliver it, to learn it in 12 weeks, it is a challenging task. You should pay a lot of effort to do it. It is not easy. Even for me, I already developed a code for 20 years, but still found many things are new, are different, because big data processing, it is new error. It is so important today. You need to know in depth, not just, okay, I know roughly in general. This is not good. Okay, we already look at the learning material activity, that's this book. Okay. Also, we will use the Amazon EMR. EMR, that is Amazon provided a platform for the that is a user, you can think about it as a user manual. That is EMR management guide. We will learn the big data processing on this platform. That is AWS EMR. Here is the menu provided by AWS. It provides many things. You can, when you encounter some problems, you can share your question in the discussion forum, discuss with me, and you can also come to this is whatever the foundations of every technician. It's a useful manual. This is the course of the duration. Now we talk about what is big data. So what is big data? Okay, all you guys come here to learn big data. What is big data? Do you guys have some idea what is big data? How big is big? How do you define this is big, that is not big? So that is obscure. So any ideas based on your experience, you can.
Fast moving or variable.
Right. Good. Yes. How many of you guys can you raise your hand if you have touched big data, this concept, not just from news or from media, you really have contact in your job? Okay. Good. Good. To which level? Oh, okay, yeah, good. Architectural level, okay, that is, you use the, okay. Big data is so popular. If you go to any business, if you go to any university, people talk about big data. So what is big data? First of all, we need to understand what is the difference, why we need to define a concept called big data. because data already exists for thousands of years, we use data to do all type of analysis. But what is big data? Today, maybe in the future, it will define in another way, but today, what is big data? First of all, let's see big. Big, that means in terms of size, okay, in terms of quantity. So the every 2 years, based on the recent statistics, every 2 years, the data generated is the whatever the data generated in the before the 2 years in the human history. So that means we already have so many data, but we look at 2021. Okay, in the future 2 years, in the future 2 years, we will generate how much data? The data is whatever we have at this moment, human generated in history. So that is exponentially increase the data size. We can see some example. The Walmart handle more than 1 million customer transaction every hour. No surprise. Okay, we are not surprised at that because around the world, all the customers log into the Walmart and purchase online. Facebook, okay. Of course, Facebook is used by billions of people, users, subscribers. It generates 3+ petabytes of user data. And tweets, another big example, that is tweets. 230+ millions of tweets every day. Not every year, it's every day. More than 5 billion people are calling, texting, tweeting, and browsing on mobile phone worldwide. No surprise, because we use it. You can think about how many data you generated. What data generated means? That means you turn on your phone, okay, mobile phone, then you begin to open an app. This generated data. That means you open an app at this time. And how long you use it, what content, for example, if it's a news stand, which news you browse. This is all data generated. So that's, on the other side, whatever you did, you are generating data. But the data previously cannot be collected, but today can be collected. So this data can be used. Let's continue, see the YouTube. Upload 48 hours of new video every minute of the day. And Amazon handles 15 million customer click stream per day to recommend products. What does this mean? This means Amazon, if you go to Amazon and there's some side, okay, both sides will pop out some advertisements. Okay. If the advertisement you are interested, you may click it. That is a click, user-generated data. So Amazon, based on whatever you browsed, it will recommend, okay, this product, or this service, or this book, or this hotel you are interested in. You click it, you are generating data. The size of the data generated, it is amazing, the size of so large. A couple of days, I just interested to check the price of a cruise, ocean cruise. Okay, I want to, maybe someday I can afford to take a cruise somewhere. I just check a couple of minutes. Then, in the following several days, when I look at YouTube, the first advertisement is about cruise. I don't like it, annoying, you know. What I just take a minute to look at the web and it keep pop out the relevant. So this is called recommendation. If I click it, that means the recommendation hit. The recommendation hit my preference. So all this, they generate profit, generate revenue to the Google. I'm talking about Google. Also the email. We send email, at least 10, 20, 30 emails I generated every day. And from the point of view of the, okay, we personal generate email, but from the point of view of the email service provider, they need to filter out spam. Okay, you need to identify which email are spam. Of course, this is another annoying point. Many useful emails cannot reach me. I just surprised. Yesterday, I make announcement using cameras. Normally, I will receive an email, but I didn't. I just not worry about it. Maybe I make some mistake because it involves a number, 100 of students. I'm talking about another class. I received an email from the Outlook this morning saying, okay, a list of emails blocked. Because based on their system, they thought they are likely to be the spam, so they block it. So this is another annoying point. But anyway, this is how the data is used and how the data will impact our daily life. Another example that is, okay, the sensors. Okay, all the mobile phone have many sensors, accelerator and geospace, many sensors. Another area used get popular, that is autonomous vehicle. The sensors, like radar and all the sensors collect the information of the car, and so the car can drive automatically by itself without the human involved. I have a PhD student, he actually studied in Germany, working on this area to collect a sensor and using a sensor to decide in which situation humans should intervene in the automatic vehicle driving. So there are many, so all these are based on collected data, managed data, and analyzed data to make our life better, to make the business more profitable and more productive, higher productivity. So this is the big data, and so data is not, why is it called big data? Why? Because data is not new. We can say hundreds of years ago, the data began to collect it. So the question is why we need a new term to say it is big data. That is, big data is a new wave or not? Of course, based on our experience, it is not new, totally new. Because whatever, for example, the customer segmentation, user preference analysis, and the many things, actually, people already collect data and try to solve these problems. But today, the difference, okay, people say, okay, why big data is different from previous? Because today the data is come from the many resources in different forms, and we must process it in time constraint to make it more value, more impact to our life. So it is yes and no. So we cannot say big data is a randomly new thing. It is not. But it did have some new characters. We need to learn the techniques to process it. This is what we're supposed to sit here for. Gartner is a consultancy business. It gave a definition of the big data. The three ways, one of our students already mentioned two of them, that is velocity and volume. Okay. Three-way, that is high volume, high velocity, and high variety. And they are cost-effectively processed for enhanced insight and decision-making. The volume, of course, volume is the size of it. It is not gigabytes, it is petabytes and zettabytes. And the speed of the data, that is the data flow in, keep flowing in. It is not a batch of data and then you do process. That is, okay, you can process a batch of data, but new data flow in. So this is velocity, and it flow in high rate. It is, if you cannot process it, that means if you have data flow in, you cannot process it in the same day. That means it have nothing, almost less value to you, because more data flow in next day. If you have processed this data, a single day data, using more than 24 hours, that means you cannot, whatever, process the data forever, because the next day, the same amount of data flow in. So you have to process within the 24 hours, such that you can update the data analysis process. The variety, that is the data, this is the three basics one, and most, whatever way you talk about, you must at least know, okay, there are three ways. That is volume, velocity, and variety. But it has been extended when the people look at it, try to increase to more way to characterize the big data. Of course, it cannot jump over the three way, that is volume. Okay. The volume, velocity, and variety are still here, but they add more, that is veracity. So if we look at the details, velocity, that is speed, the volume is the size of the data, and the variety. The variety is the data come from different sources. It can from the machine, a human process. It can from the mobile phone, can from the surveillance camera, can from the sensor installed in the vehicle. There are many ways the data can be collected. It can be from the transactions of in the servers, codes. So all this data, they can be structured or can be just the text. Okay, the message you posted in the social media. It can be structured, that means the data stored in a database. So the types and the format, the data are organized are different. This is called a variety. Previously, when we do analysis, for example, in the financial area, we just analysis the fluctuation of the stock price in history. So it's just the price, okay. Or maybe some relevant business news, blah, blah. But today it's very different. Today we may consider much wide spectrum of information, including the weather, the human income, and their traveling demand, many things. So that is the whatever the data can be collected can be used, explored for a particular analysis purpose. This is variety has been dramatically increased. Veracity, that means, in other words, the quality. You have so many different types of data from in high speed, and can we use the data with confidence? So this is a big issue. And for example, I have one staff technician in the company. I don't want to mention the name. He come to me, want to solve a problem that is entity resolution. That means they have a list of advertisements. This advertisement may be, for a long time, may be duplicated. Which one is duplicated for another one? Also, they have the registered users. They want to identify which users are actually same user. So this is a kind of data quality thing. The data quality is not only this, it's also where the data come from. For example, I have another class at the same time. The student asked me, okay, why you say the a register in the CPU is an EMR. He insists, the student check all the information, say, okay, where the EMR come from. You cannot convince me because it is first emerged in a computer education document in 10 or 20 years ago. But why? And I cannot find any information about EMR in any real CPU product. Can you explain to me? If you can explain to me, you have to remove your learning material. So this is a big issue. Okay, changing learning material is a big issue. We cannot change it without solid evidence. That is the tree, where the information we listed in the learning material come from. So the source of the data are important. There's already many studies on this one. We call it provenance. In database science, we have a topic called data provenance. That is where data come from. This is just a simple example. You can see, okay, you collect the data. Okay, where the data come from, who generated, and who processed it. Then it comes to this format. So this is so there are many topics in big data in the veracity. So some guys say, okay, veracity is also important. So this is another way. Similarly here, it can, the data in dot. Okay, data in dot is veracity as well. So the data in many formats, that is variety. Data in motion, that is the velocity. Data at rest, that is huge. The data already collected is huge. Also, people talk about the value, okay? Because we're using the data, even though it is hard to collect, it is hard to manage, it is hard to do analysis, but why we need it? Because it has value. It will enhance the insight and decision making. But why we need the insight and decision making? Why we don't make our life easier? Okay, this is a stupid question, but it really makes sense because our world in commerce, in any way, it is competition. It is a strong competition. If you don't use it, your competitor uses it. What will happen? This is if the world is not without competition, you don't have competitor. Of course, you don't have motivation to use it because we are in the real world. The real world is we need to work harder to get better, to get more information, more insight, to do better decision making. This is why if we go to talk about the industry guys, most of them today are very interested in ask us, can we use our data? How can we use our data? We have many data, but we don't know how to use it. Can we work together to find a way to use it? But this is not easy. People talk about the big data, but this is not easy. We will look at it later. All right, this is the big data, as I said, that is keep explode. More and more data are collected. This is what's predicted by the McKinsey. It's a consultancy business. In 2012, they predict, okay, in the future, that means 2015, how many data will be generated, and they talk about the big data, that is 7 years ago. But in the 2 years ago, okay, when people look back, okay, what happened? That is in 2012, okay, in 2012, this year, people predict, okay, big data is so big, okay, and here, but 2 years ago, that is 9 years ago, predict 2 years ago, and 2 years ago, it predicts, that is, this year, people do a more, the prediction again, that they will find in the 2025, the bigger we are facing, collected and to be processed, increase much more faster. Here, only talking about not data, irrelevant data. We generate so many garbage data. Here, it talk about the hypercritical data. That data with direct and intermediate impact on the health, well-being of users. Included the commercial air travel, medical application, control system, and telemetry. Telemetry, that is to automatically collect the data and pass to the server. And for example, I can give you an example, that is Vic Road, that is the government agent manager the Victoria transportation network. They have many sensors in the road network. Then this sensor automatically collect data and send it back to the center. They have a problem, that is, okay, because sometimes they have some data flow in, say, okay, something wrong in the road network. But they sit in the office and see the data flow in. They cannot make sure it is a real alarm or just a false alarm. They have this problem. They try to solve this problem, but it is not easy. Of course, obviously it's not easy. It is a false alarm or real alarm. If it is real alarm, we cannot make a quick response, it will be a big problem to the traffic, city traffic condition. But if we think, okay, it is false because it comes so often, it cannot take a response to every such kind of alarm. So we need to make a decision. So we have what I try to talk about here. That is, there's so many problems unsolved in today's when we collect data in such a way. Okay, the critical data, the origin part, that is critical data, and the potential critical data, that is the blue one. So what we talk about here is not the any data we generated. For example, we use the mobile phone, we generate data, but this is less critical. What we talk about is critical data. The critical data increase very fast, let alone the non-critical data, with the data we created every day. Like we said, big data, we collect data for values. Okay, that is, we collect data for big impact. Big data, big impact. That is McKinsey Global Institute analysis report in 2011. It predicted that means when it is 2011. In the report side, the location-based data will generate 100 billion plus revenue for service provider. So what is location-based data? What do you have ideas? What is location-based data? Location-based service. Yeah. Yeah. That is, if you go to somewhere around, then you can open your mobile phone. The location-based service will tell you, okay, if you around in MIT, if you're a tourist, it will recommend you go to Chinatown for shopping, for dinner. If you go to the Southern Cross, it will tell you maybe you can go to outlets for shopping and around. So that is location information. That is location-based service. Why it is important? Why it can generate revenue?
Impulsive. People might act impulsively if they know that this shop's got a sale on it, you're right next to it.
Yeah, yes, promotion, right? That's a marketing promotion. That's a targeted marketing. That is, you go around there, then, okay, based on your interest, I will recommend you, okay, there's some interesting point, you can go there and you can purchase something. So this is a location-based data. It's Foursquare. Have somebody use Foursquare here? Foursquare, you can check in. Okay, I'm here. If my friend here as well, we have a chance to have a chat together. Retail. Retail, it will suppose if using big data, 60% increase in net margin. A good example that is, we have some projects, student projects. They work with the course. They go to analyze the customer based on what they purchase. They make a segment. Okay, this group of customer, they like the more like meat. This group of customer like the beverage, something. This make segment. So because we can see every day cost, every transactions, we can think as a basket. Okay, in this basket, there's one very good example I can give you, that is, if we have a segment of customers in the future, then we can send the catalog, personalized catalog. We just send a catalog to everyone. Okay, same catalog to everyone. We can send the catalog just as designed for you. There's a story a couple of years ago. A couple received the catalog, talk about the diaper, talk about the formula baby milk powder, the clothes or toys about the kid of the baby. They're surprised. How this guy know that? No, we will have a baby. Then they found, okay, because they purchased the pregnancy test stuff. So they got this information. It is very reasonable to infer they will have a baby in the future. So they promote this kind of product to this customer. So this is to increase the role, the position of a company, of a course, for example, Woolworths in their customer. So manufacturing, we have projects people talk about. That is, there's a production line. Okay, produce the cigarette. They want to use their information to optimize the process to ensure the quality at the end, high quality and consistent. So we also have heard of story about the vegetable growing within the warm house, and how can measure the temperature, measure the humidity, blah blah, all the things to ensure the quality is at the end of the production is consistent and high quality. So there are many applications. That is, it's based on the data collected. Also, so there are so many stories. Another example is that is the power plant. That is wind power farm, and a number of years later on, some parts will run out. So it will need to predict which one we should go have maintenance, not too often, to cost money, and don't miss the time such that it go down, the system. So there are many, many stories about how to use the data they collected during their processing, production, producing process, a production line, then use it back to improve the optimize the production line, assembly line or something similar. So also the public sector, I'm not quite familiar with public sector, but public sector, that means the welfare of human beings, that is how to allocate the resource such that the people in need can be get a better service, public service. Also the healthcare. 300 billion value per year will increase by using the big data. So in Australia, we actually are working on that. We have last year, if you don't file application, your data, no matter where your health data generated, can be shared, right? Can be shared to any. So maybe you go to see doctor in Victoria, then you go to Melbourne see a doctor, then you go to Sydney. All the data are all referenced to you, collected and visible to people in the hospital can view that. So this is kind of how to use the big data everybody generated, then shared and managed. So that will help, of course, to improve the diagnosis accuracy. Okay, this is what people foresee in the future. And actually, this has been reviewed in 2016. Okay, the result that is, okay, from data location-based service, 50-60% the predicted target has been achieved. That's really good, isn't it? That's really good. That means 100 billion, that is 50 billion revenue for service provider. It did achieved in the past 5 years, from the 2011 to 2016. The penetration of GPS-enabled smartphone globally is a big barrier. That is, for some regions, they have phone, but they are not smartphone. It's not GPS enabled. I don't think this is a big issue. Smartphone get cheaper and cheaper, and more people will have the GPS enabled smartphone. From the point of view of the US retail, the lack of analytic talent. So this is a big issue. That is, even though we have the data and we have the data processing platform, but we don't have the analytic talent. That is you guys. Okay. I have working in the data analytics for many years, but I still think there's so many things I don't know. It's a really big topic, and case by case, it requires different techniques. The students, after they working in the course, they give a report. I need to give a mark based on their report. I have to see what they have done. It is really shallow. They just do at a very basic level, never touch the real stuff of the problem. Of course, what is the real problem? It is really depend on the business, depend on what the value part of this business required. It is hard to, I can feel it is shallow, but how to get deep, how to get more information out of it, it is a big issue. Okay, I don't know, but I know it is shallow. The many informations not it is called, we still didn't find it yet, even though the direction. Okay, from the point of view of manufacturer, that is, the data are isolated. Siloed data that is scattered in different departments of the business. So that is a barrier of the manufacturing to achieve the goals set in 2011. Okay, the similar thing, that is the data are segmented and the lack of the analytic talent. The health system. The health system, that is the interoperability and the data sharing. So this is the problem the Australian government try to solve. Okay, that means that, first of all, that means data available, data shareable, and aggregated, then can do more complex and comprehensive analysis. The data, big data analysis and management, okay, take 3 steps: data generation, and data aggregation, and data analysis. If you look at the, how many of you have already take the course, big data management? We have 2 big data courses. One is big data management. This is the second, big data processing. How many of you already take the big data management? Okay. Big data management is what we marked here. That is data aggregation. Okay, we have data. We need to, of course, first of all, before analysis, we need to have some place to store the data and to clean the data such that data quality can be improved. Then we use this data to do analysis. Actually, based on my experience and based on the information I read, the 80% of the time and the cost is on the data aggregation, data management. And only 20% of the time and the cost is on the data analysis. So I strongly suggest you go to consider to take the big data management, this course as well. So we have 2 courses on big data. So this is the big data analysis. We can see the arrow here, that is the arrow here, that is the value of the data analysis is increased in the future. And data aggregation will go no change, and the data collection generation is going down. That is, we are actually generating a huge amount of data today, and more. So, but we need more effort on the data analysis in the near future. Here is the how. It explains how the big data can make disruptive in a number of domains. So if you are interested, you can have a look of this McKinsey report. That is 2016. You can click the link, go to have a read of it, such that when you talk about big data, you will have not just heard from news, that is heard from, read from this document and from the McKinsey. It's authoritative information. Okay, we know, roughly know, okay, what is big data? Actually, we just talk about very little about it. So we have big data, we have the intention to process big data. Of course, the technologies emerges as a response to this requirement. This is the big data landscape in 2012. This is the big data landscape in 2014. This is the last year. Okay, you can see the market of the technology increase very, very fast. It is hard to see, okay, which one I should use, which one is good, which one is, really, it is a complex task. Somehow we will study in this course the fundamental one, that is the mainstream, the accepted by more than half of the market, big data processing market they are using. That is Hadoop and MapReduce. This is what we'll deliver mainly in this course. Of course, we will talk about a number of other tools we will introduce briefly later on today. We have big data. Then the big data will, of course, the purpose, the size of data, the variety of the data, the velocity of the data, decides we need to have new ideas to process this data. Then, otherwise we cannot process it. So we talk about three major points. That one is scale out, not up. So what is scale out? And what is scale up? Data-intensive workload today beyond the capability of any single machine. That is, we have a laptop and we have the desktop. We can process many jobs, but when we talk about data-intensive, for example, we process the transactions of generated a day in codes. You never can process it using a single machine. You have to use a collection of machines, and these machines are interconnected through the network, communication network, high bandwidth communication network. So we have two choices. One is, okay, we have a collection of cheap, that is commodity low-end server, or we have a collection of, we buy a small number of high-end server. Which one? We need to make a decision anyway. So if we purchase commodity low-end server, a large number, then connect them together, we call this approach scaling out approach. Another scaling up approach, that is, we have a small number of high-end servers. So which one you prefer? And you believe it will work better? Sorry? Scale out, yeah. Scale out beat scale up approach. This sounds like a story in the World War II. The Germany have a high-end tank, the Tiger, but the Soviet Union have a large number, huge large number of the low-quality tank. But yeah, it proves the low tank and tanker beat the high-end because of the high volume of the high number of the quality and quantity. So we will talk about a little bit more about it in the next week, but today we just get this concept. Because we have a large number of low-end servers, we connect together. So it is common. Failure is frequent. Here there is a small question, that is, if we have 10,000 servers, if we have this number of servers, and they together constitute a cluster. So if the mean time between failure of each server is 1,000 days, and in average, how many failures in a day? Okay, we have 1,000, 10,000 machines, 1, 2, 3, 4, blah, 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 10,000. And here is 1,000 days. And for each machine, 1,000 days. In some day, the machine will fail. And for each of them, someday it will fail, someday it will fail, someday it will fail. Then we consider all the 10,000 machines. We look at any day, how many fails happen in a day. Tens, yeah, 10 times a failure. How about the MTBF is 20 days, 2,000 days. 5, right. That's very good, yeah. So that means the manager, technician in the manager the cluster of servers face failures every day, and many failures every day. So this is the truth, okay, of if you want to purchase a large number of low-end server and collect them together as a cluster. This is the truth. You have to face this problem. So the system must be well designed and tolerated to ensure the service provided reach the expected quality. Simply speaking, that is when server go down, okay, the server is running on something, suddenly, for some reason, it goes down, and some other machine should take the job, migrate the job to another machine. So from the user point of view, okay, the service is good because somebody is working on it. If the second point, that is, if a broken server, okay, repaired, it can rejoin the cluster seamlessly. Okay, we just briefly talk about this. Another big idea, is a real big idea, is the moving the process to the data. Okay, nowadays we have the, we write Java or Python, we have a code, then we process data. Then we develop our machine, and here's the data, and process it. But when we solve a large problem, like the climate simulation, nuclear simulation, it involves a huge computing power. And we have the node computer specific for processing, for computing, and the node specific for storage. So you guys already take advanced programming, right? Advanced programming. How many of you didn't take advanced programming? So advanced programming talk about the complexity of the algorithm, right? And if complexity is powered, big O powered by 2, it means complex. But it is not complex. It is very, very, very good already. Maybe powered by 3, powered by 4. That means we have this amount of data. We need to process it a number of days, number of hours, number of months, even a huge computer. In this case, the bottleneck of the efficiency is the complexity of the computing power. So we move the data from the storage node to the processor node. Does not matter. The bottleneck is here. We can always have time to move the data here. So this is the high performance computing. But in big data processing, we talk about in this course, for example, the transactions generated by calls, transaction, something like that. This data intensive workload have the not require the processing power too much, because in many cases you will find it is just a count. Okay, we just count. Give a large data set. You just count how many of this word appears in this data set. So that is linear, right? This is it's big O 1. Okay, big O is a constant inside. That is So that means it don't require, in the problem we're talking about in this course, you will find most of them don't require big processing power. That's because the problem, the algorithm we use is linear. We just scan through the entire data set, we can solve the problem. In this sense, give me the data, I can process quickly. Such that move the data from the storage side to the processor. The processor is waiting for the feed, the data move from the storage side. So in this sense, we move the processing to the data. That means we move the algorithm to where, because algorithm is small, okay, just 1,000 lines, to where the data are stored. We use the processor, even though it is a low-end processor, no problem, it can process it. Just move the processing algorithm to the where the data are stored. So this is the big idea, big difference from the whatever previously we talked about. So moving and running the processing code to the node where are stored, it is a big idea. It's a simple idea, right? But it's a big idea. It is good because it meets the requirement, character of the problem we're solving in many data-intensive applications. Next, we will quickly go through what we will learn in this course, because I will release, whatever you can see is in syllabus, the list of topics. I will talk about each of them quickly today. Let's take a short break, 2 minutes break. Then we come back to go through the course review overview. Okay, I want to know how many of you guys have experience, don't have experience of Java. Okay, so okay, have you what?
I've written advanced programming, but I don't have experience. But I know Java.
But you already passed the advanced programming. That should be fine. If you meet the prerequisites, that should be fine. So another course, big data management, you.
But this is like prerequisite.
Yeah, this is big data management. Another one is big data. This is big data processing. Another one is big data management. So, do you want to take that one? Another one? Do you have plan to take another one?
I don't have any plan, but this is like mandatory. That's why I'm here.
Oh, okay. Very mandatory. That one is mandatory as well.
Management should we do that big data management after this?
Does not really matter. Does not really matter.
There's no sequence.
No, because they are quite
This big data management relates to how the data is ingested, how it's stored, and how.
all the data are managed in a database. Somewhere you need to store the data. Be sure the data are psychologically important. Yes, yes.
You wouldn't notice a thing.
Oh, okay. Yeah, don't worry. It's recording.
process if we miss something. During
Yeah, the size of the squares. Okay, let's start. We have many things to talk today. Okay, now one thing that is I may upload a version of the lecture notes before the lecture. Some students ask because the size of the font is so small. So normally we have a big two screen, but at least only one smaller screen. So I will upload one, but don't treat that one as the final version. I may make upload after the lecture, the new version of it. So this is the first week. Okay, in the second week, we will talk about the Hadoop. HDFS and Yarn. Before we talk about Hadoop, HDFS and Yarn, we will talk about the data center. That is, okay, the data where data stored. You cannot store the huge petabyte data at home. Of course, it is impossible. Also, when the data flow in, keep flowing. You cannot measure it, so we have a data center. Data center is a big business. It's like a big country. It consumes a huge amount of power to store the data, to provide a service. So we'll talk about data center. Of course, we will talk about not in much details. We just talk about the, very briefly talk about it. Also, the cloud computing. In the early days of computer emerged in the world, and scientists say, okay, in the whole world only need a couple of, no more than 10 computers. Yeah, this is well known, okay. What he said is true, okay. Today we found it's true because in the future we just need a supercomputer, a number of supercomputers. Everyone have a low end, user end. We just have a computer actually connected to the cloud inside. This is a tablet. Okay, tablet is low end. Then we connect to the server, download the application, download data, and so this is coming true today. That is, we only need a number of computers. This is through the cloud computing. Cloud computing. utility computing, everything as service. Okay, we will briefly introduce this infrastructure as a service, platform as a service, and software as a service. What's the difference between them? What's the commonality among them, and what's the difference between them? Then we will look at the Apache Hadoop ecosystem. First of all, that is the foundation of everything, that Hadoop distributed file system. The data we cannot. Previously, the simple way we can download a database MySQL or something to manage the data in a database. But based on my personal experience, I have been working with a telecommunication company. They collect a huge amount of data. So they just collect the data, then they throw the data. Because they don't have place to store the data. So they build a system, spend their couple of months to store the data they collected in 1 month. They try to store more data. You can see if they store more data, the old data have been emptied. The storage system disk has to be emptied for the new data. So stored data is a big issue by itself. So HDFS, that is Hadoop distributed file system, try to store huge amount of data. And when the data grows, it just allocates more storage, and all the data will maintained for next processing the next step. The YAN is the yet another resource negotiator. That is to manage the computing resource based on the HDFS. The function of YAN, previously it is come with the MapReduce, but later on in the MapReduce version 1.0, it separated. The manager of the computing resource is integrated together as a YAN. Okay, then in the week 3, we will talk about some useful tools currently for well-known. Okay, these tools are well-known. If you're talking about big data processing, the PIG. A PIG, that is the circle, actually, it is a circle, SQL, to query database. But it, of course, you can query a data set by writing some program. No problem, you can do it. But PIG, just like the Oracle, it provides descriptive language such that you just describe what you want, then the system will do the rest for you to retrieve the data and present it to you. You can see the PIG is it is a real PIG, it is here. It is here. Then in the week 3, we also talk about Hive. Hive is a script written in Hive is data warehousing application in Hadoop. Another tool we will talk about is the Manhot. Manhot is the data mining tool. It already provides, for example, k-means, fuzzy k-means. These tools, so you just use it like a function. You invoke it, and the Manhot work on the Hadoop such that it means it is not a simple k-mean, the clustering. It is supposed to process a large amount of data on Hadoop. Also the Maven. So any of you here ever heard about PIG, Hive, and Manhot? Okay, good. Maven. Anyone heard about Maven? M-A-V-E-N. Yeah, good. You heard about Maven. You told me you're not good at Java. Okay, Maven you will find Maven is very useful. Whatever you write out in Java, you can use Maven to package it together. It's a very useful tool. You specify the dependency, which package is required, and it will collect everything together, such that it is a self-contained software package. We will talk about Maven as well, because as a useful tool, you developed it, you cannot just write a simple code like whatever you did in your study as Java and Java compile it, something like that. You will package it together as a ready to use software package. In the week 5, we will talk about the MapReduce basics. Okay, MapReduce. Okay, see here, MapReduce is at the corner. This is the MapReduce. In the MapReduce, this is the processing diagram. You can think of the flow chart of the data processed in MapReduce. MapReduce has its own execution framework. That is, most of the work actually has been done by the execution framework. So it gives you a lot of not convenience, but on the other side, that means what you can do is very limited. You need to only work on the map. Oh, this is a method. Reduce, partition, combine. You only need to work on these two functions to specify what you want the system to do for you on the data. We will, in the week 5, we will introduce the concept of the shuffle and the sort and how the data flowed in the nodes of the cluster such that together to process the tasks you specified. We will also introduce the combine function with more tactics, okay, to improve the efficiency. We will talk about the combiner, in-memory combiner, and how this will impact the performance. And we will get more and more complex after that. we will use the MapReduce to solve some problems. Even though these problems, if we don't talk about big data, is simple. For example, in week 6, we will talk about a problem we call it a co-occurrence matrix. We want to generate a co-occurrence matrix. That is, for example, give you a Bible. Okay, the Bible is very this size, okay, normally this size. If we take every word in the Bible in the column like this, in the column, if we, okay, this is each word in the Bible, okay, how many words we may have? At most, a dictionary, okay, the vocabulary in a dictionary, right? And if we treat each sentence, if a same word, another word appear in the same sentence, we consider it called a co-occurrence. Then we can list the word, co-occurred word here. Then if, for example, read, for example, the read, and in a sentence, also I read. Okay, I will be a co-occurred word of read. Okay, then I just count all sentences in the Bible, read and word appear in the same sentence, the number. So that's easy, right? 1,000 times, 10,000 times. You just give you this task. Can you do it quickly? So this is what week 6 we will talk about. That is generate a co-occurrence matrix for a text collection. Bible, maybe the Wikipedia, any English written documents. We just count that. Can you do it? So this is the co-occurrence matrix. We will, of course, this is a big task. Simple, but big task. So we will discuss a number of approaches. How can we speed up the processing time? So we will talk about the Pierce approach and the Straps approach, and compare the difference of them. Also, we will talk about the how the MapReduce do the join. Okay, if you have database background, you know join. Okay, that is student ID. This table contains student personal information. This table contains what he got in every courses. So we need to combine them together such that this student personal information and the grade in all courses he have a tick. This is join. Also, there's an inner join. Okay, that is whatever we can find a match, then we retain it in the result. The left join, that is only the match to the left table, we retain it in the result. Or the outer join, whatever appears in the two table, then we list it. If there's a match, we just list all the information from both tables. If it is not, we just leave it none. Okay. How can we use if suppose we process a large table, how can we use the MapReduce, this execution framework, to process the large size join? It can be reduce size join or map size join. That reduce is here, map size join is here, and memory backed join. That is, we suppose explore the memory of the local machine to speed up the process. Don't be scared. Okay, this is after the lecture you will find. Okay, execution framework of Hadoop already do most hard job. What you do is very limited. Okay, as a technician, as a data analyst, actually you just focus on map, reduce, partition, and combine. But what we try to lecture you to know, that is, okay, should I do this way or that way? I will let you know, make a judgment. Okay, should we apply more function on map or reduce, or combine, or whether should we use memory to in the combine? What is the advantage and disadvantage of it? So we try to deliver, not try to solve these hard problems. We try to, when we're solving this problem, we try to let you know, okay, the pattern of a good design in Hadoop execution framework. Okay, in week 7, we need to work on a particular problem, solve problems, then we learn the pattern, then we learn how to solve problems. So we will, in the week 7, we will work on the clustering and the classification. So what's the difference between the clustering and the classification? If you know it, can you raise your hand? Okay. Can you say the difference between them?
Clustering, you group similar things together, and so when you have a cluster, things within a cluster have high similarity, and there is very low similarity between two clusters.
Yeah.
And classification, you can either supervised or unsupervised, where you basically you have a trading data set, you have a test data set, and so based on the trading data set, you finally classify or you finally predict a new data entry as to what it is going to be.
It's depend on the targets hit
That's based on the target variable.
Okay. Generally, you guys are right. The cluster is unsupervised learning. What does unsupervised learning? That is, you have no knowledge of label. What's this label? That is, for example, that is based on the diagnosis of blood test. This person has cancer or do not have cancer. It's 0 and 1. This is label. But if we don't have the cluster, okay, we just based on the, when we talk about clustering, that means we don't know the label. We just cluster the patient based on their blood test. If they have the similar result, we group them together. Whatever the person inside a cluster, they supposed to have a similar blood test result. The person in between enter the cluster, they supposed to have dissimilar result. There have many examples here. Here's the age and the salary. If it is age and salary, the risk of the loan repayment risk, we don't know which group has high risk and have low risk. We just group them together based on their age and their salary. 2 dimensions. Can be more than 2 dimensions. You can include much, much more than dimensions. Okay, based on their occupation. Sorry? Yeah, many other factors. Whatever you can imagine, you can add as a dimension, such that you group the people together. If they have similar, we call it features, age, salary, we have, in this case, we have 2 groups. But which group have high risk? Which group has low risk? We don't know. We don't care. We just group people together. This is cluster. We can cluster the students sit here into groups. Okay, this is a cluster. Okay, this is a cluster, and this cluster, and this is a cluster. That's all. Just a group people. We call it cluster. What is classification? Classification, that is, I have some knowledge based on my previous experience. The people sit here more likely get HD. People sit here more likely get D. People all sit over here, just for example, okay, not pass, okay. So this is label. If I have many years experience, I can use this one to label, okay, people sit here. Sit here is actually the dimension feature, okay. Another example, that is diagnosis of blood test show, based on many patients, we will say, okay, this blood test result is very likely to indicate in the future the risk of cancer, that is 1. And another type of blood test result will indicate 0. That means low risk of cancer. But that does not mean absolutely correct, but it's very likely. So this is the classification. That means based on previous years, many years history experience, we say, okay, if it has this age and salary, it has high risk of the loan repayment. So we will have a model to indicate. We will train a model first based on the history. Then we will use it. Give any, in the future, give any age and salary I throw it into the model, it will tell me 1 or 0. That means 1 is high risk, 0 and low risk. So this is classification. It's clear now? If you have questions, you can ask me, we can solve it now. Okay, we will use MapReduce, this execution framework, to solve the problem. Why this problem? Because this problem is hard to solve, so we use MapReduce. And we use Hadoop to do it. Very simple, just a very simple point. That is, if we want to measure the distance between any 2 points, we need to measure my distance to you, my distance to him, everyone. I need to measure my distance to everyone. And you have to measure distance to everyone as well. So that is, if we have 100 students, how many peers measures we need to have? 100 into 100. Sorry?
100 into 100. 100 into 100.
100 power 2, right?
Yeah.
100, that is 10,000 pairs. If we have 100 people, we need to calculate 10,000 distance, because everyone needs to measure distance to every other. So, am I right? Am I right? Okay. It's simple, but it's, then we can go ahead. That means if we have 10,000, that means 100 million pairs. It increases very fast. So, but we have to calculate it for clustering, because we know the distance, then we can cluster it. MapReduce provide the possibility to, because the calculation of distance are independent operation. Okay, I calculate distance from me to you, and from the calculation from you to another person. It's an independent operation. So this operation can do independently. So they don't influence each other. So this provides opportunity to process in parallel. So this is just one point. In week 8, we will try to apply the MapReduce, the Hadoop execution framework for processing large graph problem. PageRank. Everybody heard of PageRank? Okay, yes. PageRank is well known. It is the Google's first algorithm. We know Google, the business is to information retrieval. That is, give you a query keywords, it will reply a number of relevant pages to you. So the page is following the name of the Larry Page, the founder of the Google. When he was a PhD student in Stanford, I think Stanford, he wrote a paper named the algorithm PageRank. That is, every homepage has a link to other page, and every other page have a link to other page. So if we give a few keywords, for example, large graph processing, then we randomly found some page as a seed. Okay, it with the large graph processing. Then we always come from these pages, then go out, then go out, then go out. Eventually, we found we will arrive a few pages, many rounds, many click. Then we found we will focus on some. Finally, we will reach some pages. This page is more important in terms of this large graph processing, these 3 keywords. So this is the basic idea of PageRank, but of course today Google is much more complex than that. We will look at how the PageRank problem solved in the context of Hadoop. Also the shortest path algorithm. Shortest path is a very important problem. If we use the navigator, Google Navigator, we go to the airport, it gives me a number of paths. These paths can be based on the kilometers, or based on the time spent, or based on something, but they all based on the shortest path solution, solve the shortest path problem. Because the shortest kilometers, shortest effort, or shortest congestion, they are all means shortest in terms of something, kilometers or congestion or something. If the graph is small, okay, for example, this one we can see, okay, it is easy from A to C, C to E, E to D, then to F. From A to D, the shortest path is this one. But how about this one? How about give you a road network of the Melbourne? But it is really complex, right? But this problem is a classic problem in computer science. It has been studied 50 years, beautiful solution already there, but we will resolve it in the context of the Hadoop. That means if because we talk about if the road network even is simple, if we talk about the social network, okay, social network, you can imagine how many nodes they are there and how many links are there. So between calculate, for example, the group of users in Melbourne to the group of users in the US, whether they have influence to each other, we can somehow, based on that, to extend the distance to influence. Okay, so there are many problems beyond the road network shortest path in the Twitter, the follower-followee relationship. Their form of network. So it gets very complex, so we need to process it. We cannot using the traditional way to process it because it's too complex. So how can we solve it in the context of Hadoop? Then the next solution is also very practical. That is Google. Okay, Google provide a quick information retrieval solution that give any keywords, it reply you to the page and rank it. The first page, top 10 pages. How this can be done for any, for example, pin for Baidu, the Chinese version of Google, Chinese version Google. So they all based on something data structure. We call it inverted index. That is, okay, this is a word. For example, this word is Melbourne. How many pages? This is a page contain the word Melbourne. Another page, web page contain Melbourne. So we have a long list of all pages contain Melbourne. Whenever you type in or query Melbourne, then Melbourne Central, maybe for example, Melbourne Central, the pages all contain the word Central. We will find from the list of the following this term to find the page is most relevant to Melbourne Central. Okay. So this will speed up the search process. How this data structure are constructed. Okay. So it is important. It is the core of any search engine, Google, Bing, Baidu. I think they're already highly manipulated by this a number of search web server search engine. Even though there's a good story because the information retrieval search engine, really, the foundation of search engine, the core, technically we call it information retrieval. RMIT is one of the top 10 best university have a research team in information retrieval. It's led by Mark Sanderson, Shen, and Falk. They are well-known researchers. But we always have a joke together, say, okay, the search of the provided by MIT website is so poor, can we do something on it for it? So the solution, okay, it's better to go to Google, and Google can provide a better solution. Because it is not only the, today, it is not only the techniques, it is only involve many engineer things, stuff. How can we improve the search response speed and accuracy? Okay, the week 10, we will talk about the another very interesting topic, that is statistical machine translation. Okay, we use the Google Translate. Type in any paragraph, it will generate so accurate translation. So I often use it because I have some document in Chinese. I just translate it to English. I just change a few, then I have a good document in English. It's so good. So we will look at this problem. We will, of course, we cannot look at the inside of Google Translate. We will solve a problem that is the foundation of Google Translate. They all share the same ideas. The idea is, okay, for example, this is a sentence. This is a sentence in English, and we want to train a model such that we give the parameter of this model. It can produce for example, any other language, the same meaning of this English sentence. So the problem is, how can we get this one? How can we have a model. Then how can we get the parameters such that the model useful? Okay, in the future, any sentence given here, based on the parameter, it can generate the corresponding equivalent sentence in other language. So we will use the expectation maximization algorithm to find the proper theta. Their implementation in MapReduce programming framework. What we talk about here has been well studied. If you, in the future, if you work on PhD study, you are interested in natural language processing, you will find so many solutions, so many researchers, publications every year. But what we talk about here, how can we use MapReduce to solve fundamental problems in this area, in this topic? Then in the week 11, we will talk about Spark basics. We talk about MapReduce. Why we bother to talk about Spark? Because if you go to do some research, you will find that the Spark have a chance to replace MapReduce, but somehow they have pros and cons, advantage and disadvantage. I don't think they will replace to each other. But somehow we let you to have some touch of Spark. See the difference between advantage and disadvantage compared to the MapReduce. Spark is here. It can, based on the YARN, based on HDFS, and it can also run without the distributed file system. Then come back to look at the big data landscape. What we learn is a very small corner of it, but it is the foundation. That means the mainstream use, what mainstream is using, that is MapReduce, Hadoop, HDFS. After you know this, in particular, when we, the programming patterns, when we're solving a list of problems I just introduced, you will have some foundation to understand. You can start to learn more advanced course, or you learn by yourself to be an expert in the big data processing. Another, the last important thing, that is the lab. The lab will, based on the AWS EMR, that means Amazon Elastic MapReduce EMR, Elastic MapReduce. We already generate accounts for all students based on the roster last week. But I found that there's a little difference. We have 120 who enrolled last week. Okay, I will send an email and pass the password of the jump host. That jump host is a server of the AWS. I will send an email to share the password to you, so you can download from Google Doc. If you guys, after I send all the information out, I will make an announcement, send an email.